Hey, it's me, Oscar from the Coding Universe, and this is what we're going to make this tutorial. No tricks involved here, this is real 3D using the lightweight Java game development, so let's get started with episode 15 of Java game development. Of course, the bread and butter of this episode will be the gluPerspective method, which sets up the perspective. Now, I've created a class called 3D Demo, and instead of me typing and you looking at what I'm typing, hearing all the annoying typing sounds, I have decided I'm going to try a little different way to doing this. So I've written all this code with comments, and I'm going to explain it bit by bit. So let's start at the top where I initialize the display. Nothing new here, so let's head on to the next one. Instead of the glOrtho method we used to call earlier, I have replaced the glOrtho method with a gluPerspective method. The gluPerspective method takes 4 parameters. The first one is the field of view in degrees. The second one is the aspect ratio, also known as the width divided by the height of your window. The third one is the z_near argument, which says how far in objects can still be to be rendered. And the last one is the z_far parameter, which sets the amount of distance, the maximum amount of distance for objects to be drawn. Now for the first parameter, I have chosen 30 degrees as an angle for field of view. For the second parameter, the aspect ratio, I divide the width of my display by the height of my display. So that would be 640 divided by 480. The third one I set to 0.001 f. And the fourth one I set to 100. Now to initialize the random points you saw, I have created a static nested class called point, in which I simply declare 3 variables, x, y, and z. Okay. So I create an array of points of size 10,000, and I also initialize a new random. Random is a class provided by the Java libraries, runtime libraries, which allows you to create random numbers. Then I iterate over every array index in points. And in here I set the point at the array index to x is a random between -50 and +50. So we have here random.nextFloat, which returns a float varying from 0 to 1. I do that, subtract by 0.5. So now I have a random number between -0.5 and +0.5. And then I do times 100, so between -50 and +50. The next one, the y, is exactly the same. And the last one, z, simply says random.nextInt 200, which says that that the Java runtime libraries have to return a number between 0 and 200, and then do -200. So now we have a value between 0 and -200. One thing to note as well with the gluPerspective, the display or coordinate system on x and y basis varies from -1 to +1 on both sides. So plus x is going to be to the right, plus y is going to be to the top, and plus z is into the screen or to the camera. So when I want to draw a triangle at a set distance away, I say GL begin GL triangles, GL vertex 3f 10 10 minus something. It's important to not forget that the z value should be negative instead of positive, else you can't see it. Then we declare the speed in which the camera travels, or well, the display is pushed in, because that's in fact what's happening. The speed is defaulted to 0. Then I clear the screen, I clear the color buffer bit and the depth buffer bit, and I also push the screen inwards at the amount of speed. So I use the method glTranslateF to accomplish this result, and what it basically does is it pushes the screen inwards, or you could also see it as pushing the camera forwards at the z-axis with an amount of speed. Also note that I did not call GL load identity, so the matrices will be consistent throughout the display main loop. Then I start to draw points, so I call GL begin GL points, and then I iterate over every point in the points array we declared up here. I also put a vertex GL vertex 3f at p.x, p.y, and p.z. So I basically just draw the point at its coordinates. And lastly, I stop drawing points by calling GL end. Now for the input. If you haven't already noticed, I can control the speed by pressing the up key. So when I press up, the speed increases, down decreases speed, space resets our speed, and C resets our speed and our position. So it's just really basic here. If keyboard is key down, keyboard up, increase the speed. If the down key is pressed, decrease the speed. Then I iterate over every single keyboard event and say if it was the spacebar key, reset our speed to 0, so speed is 0, and else if we're pressing the C key, reset our speed to 0 and reset our position. So I'm going to call GL load identity, which resets the matrix so that all these translate F functions do no longer have effect from the past time. So all translations are wiped. Also, one thing I forgot to mention is that I statically imported org.lightweightjavagamelibrary.util.glu.gluperspective. So that's how I could use the method gluPerspective. Okay, so let's mess around with it a bit more. I'm actually really proud of this. You can also see the points are popping in from the distance. That's because they aren't rendered because they're farther away than z far. So that's pretty cool. You can also see them disappearing if I go backwards. Pretty cool. Okay, this was episode, what is it, 15? Yeah, 15 of Java game development, and bye. Till next time.